Okay, so this is your circuit for the hardware and also for the simulation. I will give you the same circuit. This is lab experiment number 4. In exam lab experiment number 4 and 6 will come. So in the hardware we don't use 1 kilo ohm resistor, but in the simulation you have to use 1 kilo ohm resistor also. So let's go to multisim and try to make this circuit. And also in the exam I will ask you, first we will make this circuit. Okay, so this one is potentiometer. Okay, if you go here, you go to basic and you go here, this is potentiometer. Okay, this is a variable resistor. From here we will change the resistance to check the gate voltage at this thyristor. Okay, and this thyristor number is 2N1599. You will go here all groups and you will write 2N1599 this number and you will get it. Rest of the things you know how to bring it. For the function generator, you will make this setting. 50 hertz is frequency, 10 volt peak is the input voltage, AC voltage, and I put 5 volt offset. I will tell you why I put it. And then you will connect plus here and negative of oscilloscope here. Okay, when you run this and then you open this, you can see here this is our output. Now in the exam I will ask you, I will give you the value for the for this resistance, variable resistance, and I will ask you to calculate angle at, for example, I say you 95%. So what you will do, you will make this 95%, and then you will see here. And this one, you can adjust it from here. For example, you can make adjustment. You can decrease the frequency here, and you can make it big or small like this. Why I made this 5 volt offset? If I make it 0, what will happen? This is not coming like in the screen, so that's why I put 5 volt offset. Okay, you can adjust offset according to your need. Okay, now I asked you that make a potentiometer setting as 95%. For example, I ask you in exam, I will ask you a different, maybe I ask you 85. So what you will do, you will make it at 85. Okay, and then pause it, and then you go here, you make one cursor here and another cursor here. Okay, now look here. How much is the time delta t? This is 2.296. Okay, what you will do, 2.296. So the we have alpha equals to omega t, is omega is 2 pi. 2 pi is in degrees is 360 multiplied by 50. 50 is the frequency multiplied by this delta t, which is for 85%. This is 2.296. So if you multiply it with, I make it with calculator. You will make it like this. So from here what I get, 2.296, 2.296 multiplied by frequency 50 multiplied by 2 pi, which is 360 degrees. So this is 41.3 and this is millisecond, so it will become 41.32. It means alpha at 85% of variable resistance is 41 degrees. Okay, so please remember that I will ask you about this. Maybe I ask you make it 45% and then get the angle. So then you have to run it and then you have to check how much is delta t and then use this delta t in the formula. Okay, so I will see this adjustment. So this is 2.07. What you will do, you will make it 2.07 multiplied by 360 multiplied by 50. Please remember this formula. So this is 37 degrees. Okay, and in the hardware, so this is for the simulation. For the hardware, you will use the same circuit, and for the hardware you will find this t, delta t. I will give you the angle. In the simulation, I will give you the variable resistance. In the hardware, I will give you the alpha, and then you will find this delta t. Okay, so please remember this. So this is about multisim. And experiment number 6 is very easy. Experiment number 6 is about Experiment number 6 is this. So how you can bring this transformer, you go here and you go to 3D virtual and sorry, rated virtual, and here this is the transformer. Please, you have to remember this, how you get these components. I will not tell you. And the next thing is how you get this RMS voltage. So you go to sources, you go to power sources, and you go this. So this is VRMS. Okay, so remember how you bring these components. Rest of the components you know how to bring them. And you will first use without capacitor. Mm, you will first control X. You will first get this waveform. So okay, I have to stop this first, and first you will get this waveform. Okay, so this is full wave rectifier without any capacitor. Okay, the function of capacitor is to remove the ripples. Okay, I can maybe also ask you what is the purpose of taking capacitor, and also you will calculate the ripples amplitude like this, one cursor here and one cursor here. Now the ripples amplitude is 14.032. Okay, I just want to remove this negative sign, so make cursor 2 here, cursor 1 here, this will remove, so it's almost 13.77. Okay, now these are very high ripples. So how you can remove these ripples? You will put um, capacitor in parallel with the resistor, and this capacitor value will be different for each student. So yes, now you can see that ripples are reduced, and you can check the amplitude of the ripples with the cursors. One cursor here and another cursor at the peak. 3.9. So it means this reduced the ripples. So that's all about your experiments. So please be very much focused about the value of the potentiometer value I give you, and then keeping this in mind, you have to calculate alpha. Okay, in hardware I will give you angle alpha, and then you have to find delta t. So remember this formula. Okay, so that's all.